Hi, Lorenz. Good to have you here.
Hi, thanks for having me.
Uh, Fantastic. So I will introduce you shortly, and we will ask some questions for the IPM. Lorenz Demey is a research professor in philosophical logic in Leuven. He does research in logical geometry and the history of logic. He's going to tell us a lot about that today. And he recently got an ARC starting grant of the European Research Council to carry forward his projects on this. So Lorenz, I was thinking about asking you, of course, about the ERC research grant and your plans in the future. But also this project clearly builds up on your previous work on this topic, on logical geometry and on Aristotelian diagrams in logic and its history. We can talk about the ERC in a minute. I was wondering if you could say something about the other projects that led up to this one.
Okay, sure. Yeah, there's. I like to call this my personal prehistory of arriving at logical geometry, arriving at this this research project, because my PhD back in 2010, I started as a PhD student, was actually about a topic that is quite different, namely epistemic logic, in particular dynamic epistemic logic, and trying to link it with probability theory. And my PhD itself was about that, and I also finished my PhD and submitted my dissertation ultimately in 2014 on that topic. But somewhere along the way, I got hooked on these Aristotelian diagrams, the square of opposition, and many other more complex diagrams. And first, my feeling about them was very much the feeling that I think many people in contemporary logic and analytic philosophy have, namely, it's this old-fashioned thing from ancient and medieval logic that we all learn about in our introductory logic course, and then we never look at it again. But my own impression was there's much more that we can say about this also from a contemporary formal perspective. So I started getting interested more and more in this. My very first publication, which I really like because it really shows the transition from public announcement logic, dynamic epistemic logic on the one hand, to logical geometry, dates from 2012, so smack in the middle of my PhD trajectory, was about Aristotelian diagrams for public announcement logic. So after the PhD, my first and second postdoc were completely dedicated to logical geometry, to studying these Aristotelian diagrams. And then now my research professorship at KU Leuven is also almost exclusively dedicated to studying logical geometry, and this has now culminated, of course, in the ERC project that is about to start coming in September. Along the way, there's also been some other projects that I've run. So, for example, in 2018, we had a project together with a colleague of mine, Hans Messart, who works at the Department of Linguistics, Formal Semantics, Pragmatics, and so on. He's a very good colleague of mine. We have collaborated a lot, and also this project that I'm now talking about, we ran together. And this project involved the creation of a database of Aristotelian diagrams, because we had the feeling that until that point, a lot of what we were doing and also what other people were doing, but also we ourselves, we were also guilty of that, was very much armchair philosophy or armchair history of logic, you could say. So we were building all these grandiose theories of what Aristotelian diagrams are and how they work, mathematically speaking. But at the end of the day, we asked ourselves the question, well, what are we really doing? What are we talking about ultimately? Just some mathematical fictions, or is this really still supposed to be about something that we really find in the literature, in the medieval manuscripts, in the early printed books, and so on? And we noticed that what a lot of people do is they always return to a very small set of very well-known Aristotelian diagrams produced by very well-known authors. You know the names. John Buridan is a typical example. I have published myself on Buridan. Many others have done so. And that's for a good reason, of course. He is really interesting. But on the other hand, yeah, it also means that the history of logic is a very fragmentary one, and there's the risk of bias that we might run if we only focus on these kinds of diagrams, these kinds of authors. So with this database, which is now available online, it's not yet finished by no means, but it's called Leonardi, the Leuven ontology for Aristotelian diagrams. The goal is to get a much more comprehensive view of all Aristotelian diagrams, not just by the big canonical authors, but also by the much less known ones, not just the very famous square of opposition for syllogistics, but also a much weirder looking diagram for a much weirder looking logical system. So that we have a comprehensive overview of all Aristotelian diagrams that have appeared somewhere, so that if we now want to sit down and start some logical mathematical theorizing, we will have to make sure that this theorizing not only matches with the very well-known Aristotelian diagrams, but also with these lesser-known diagrams. So that's one project, apart from my own personal postdoctoral fellowships that I've been running. And maybe one more that I want to mention already now, because it's also gonna, I think, feed into the ERC project that is about to start, is a project about vernacular logic. This has just started up. It's really recent. And I'm running this together with Christophe Geurens, who did his PhD also under my co-supervision, and also Rafa Roy, who is about to be appointed as professor at the Latin literature section of KU Leuven. And this project is about the earliest logic textbooks in the Dutch vernacular language. So we're talking about the late 16th century here. The Middle Ages are more or less finished. But of course, they still have a long aftermath, especially in certain parts or certain academic circles, let's say. Until then, at least in Western Europe, logic was, as all scientific disciplines, written in Latin. But at this point in time, we see the publication of logic textbooks in all the vernacular languages, English, French, Italian, but also Dutch. And for these other languages, there has already been quite some research on those earliest textbooks. But for Dutch, until now, at least, not really. So that's also one of the things that I'm interested in, and that we are already working on, but it's still very early, that we're especially gonna be working on in the next few years. So this is that this also nicely slots in with my research on Aristotelian diagrams, for the obvious reason that many of these textbooks on logic in Dutch also contain squares of opposition. So for example, one of the things that we want to investigate is the creation of a Dutch vocabulary, of a Dutch technical vocabulary. If you are the first writer ever to write about logic in Dutch, it involves the creation of new words. All these words only used to exist in Latin. Now they have to be translated. You have to create new words to express these things: argument, fallacy, contrariety, subcontrariety, when you're talking about the square of opposition. And it's really interesting to see how all of this plays out, how different authors use different strategies for creating for creating these new terminologies, also and especially in the context of the square of opposition that they describe. So I think in a nutshell, I could go on, of course, but in a nutshell, that is some of my own personal background, and then also some of the projects that I have been running in recent years that are all centered around logical geometry, Aristotelian diagrams.
Right, thank you. And your RC project, congratulations for it, will start in September, as you just mentioned. And if I'm right, it's called Start Dialogue, and it connects with your previous research. But I also wanted to ask what lies ahead with this project, and what are your plans for the next years while you are running it?
Mm-hmm. Yeah, so the project's acronym is START Dialogue, which stands for Towards a Systematic Theory of Aristotelian Diagrams in Logical Geometry. And the title is more than just a fancy name that we put on the project. I really mean it. Every word in the title is important. What we really want to do is achieve a systematic, coherent, unifying theory of Aristotelian diagrams, and we think that the best candidate for that, of course, but here I'm biased, is logical geometry. So the idea is if we look at Aristotelian diagrams, all this research that I myself did, but also that many other people did in the last, let's say, 15 years, there's a lot of interesting results about Aristotelian diagrams, historical case studies, but also theoretical results. But if you look at it, it seems to be very much in this array. It's just a loose collection of isolated results. And one of the things that we want to do is really take all of these results and try to unify them, as I said, try to make them into a single theory that really hangs together quite nicely. And that's what I want to do with logical geometry and institutionally speaking, let's say, in the context of this ERC project. So there's a couple of goals that we have. On the one hand, there's a strictly logical goal, which means that we're going to continue building a logical perspective on Aristotelian diagrams. There's already a lot of work that has been done by others, by myself to some extent, but we're really going to try to unify that. Just to give you one example, the informal notion of contrariety, which is one of the relations that we find in the square of opposition, says that two statements, two formulas, two sentences are contrary to each other, if and only if they cannot be true together, but they can be false together. Now, if you want to take a more formal perspective on this, which is of course something that we want to do in logical geometry, we want to take this ancient wisdom of the square of opposition and try to translate it into formal mathematical formalisms. There's not just one unique way of doing this. You can do it in multiple ways. You can capture this idea of two formulas not being able to be true together in multiple ways. In various systems of logic, all these ways are ultimately going to coincide with each other. So that's the kind of robustness result. But in more non-classical logics, like paraconsistent logic or intuitionistic logic, they tend to drift apart. They diverge from one another. And then you're going to have, for example, a stronger notion and a weaker notion of contrariety. And then you can ask the question, well, is one of these two to be preferred over the other one? How do they relate? When I say one is the stronger, one is the weaker, I'm already saying that there is a kind of relation, namely, if I say the first one is strong, the second one is weak, I'm saying, well, if two formulas are contrary to each other in the strong sense, then you would expect, if the terminology makes sense, that they're also going to be contrary to each other in the weak sense, but not the other way around. So that's basically the logical part of the ERC project, trying to look at these kinds of things, and especially trying to unify them, and not just look at the strong contrariety, the strong generalization of contrariety in isolation, and the weak generalization in isolation, but really look at them together, try to establish interactions between them. Then there's the what I would like to call the empirical part of the project. So the empirical part builds on this database of Aristotelian diagrams that I was already talking about. We're going to continue to expand this database. Until now, all data input has been done in a completely manual way. So me and some colleagues and some student workers have been looking at digitized manuscripts, journal papers on GStore, physical books for diagrams. We scan them, we photograph them, we provide very detailed annotations, and we put them in the database, and that's it. One of the goals in the ERC project is to try to automate some of this. So we're going to try to apply some machine learning techniques, computer vision, and the idea being that you give as input to the algorithms a PDF, for example, of a manuscript, and then as output it gives you, let's say, a list of pages where the algorithm thinks there might be an Aristotelian diagram. Of course, at the end of the day, there's always going to be a human check before something really ends up in the database, kind of quality check. But that would speed up the process a lot, and it would also allow us to cover far more ground than would be possible purely on a manual basis, as we have been doing thus far. Right now, we are at slightly over 2,500 diagrams in the database. I think applying these machine learning techniques like we're going to do in the ERC project will help us to quickly move in the direction of 6,000, 7,000, 8,000 diagrams. And then the database will be really comprehensive, which is not just the goal in itself, but also really important as this kind of check on our armchair theorizing. Remember what I said earlier? If we want this database to control for armchair theorizing, well, that's only going to work if the database is truly comprehensive, because you could say that right now there is still a bias in the database, namely a bias for those manuscripts, those books, those research articles that are easily accessible, that have already been digitized, and so on and so forth. If you really want to debias that part of the research, it's going to take much bigger efforts. At least some of them will have to be automated. And then there's a final set of questions that we want to address in the ERC project, which is what I would like to call the philosophy of Aristotelian diagrams, the philosophy of logical geometry, perhaps. So then the question is no longer what are Aristotelian diagrams, how do they work, what are their empirical features, like how are they distributed, when were they used a lot and when were they used a bit less frequently, in which countries were they used a lot and in which countries were they used less frequently. That's all the kind of stuff that we're going to study by means of the database. But there's also this fundamental philosophical question: why Aristotelian diagrams are so useful? Why are they used in the first place? The answer that you get by almost everybody is, yeah, they're pedagogical devices. They are teaching tools. They are tools that we use to teach logic to students, some of them perhaps not so keen on studying logic in the first place. So they are a nice visual tool. But in principle, you don't really need them. And especially for the smartest students, you don't really need them. And I'm sure that is a part of the answer. I don't want to deny that. But I really have a very strong feeling that it cannot be the entire answer. Because if that were the entire answer, you would be totally unable to explain that if you look at today, if I look, for example, at the last 5 years, the Aristotelian diagrams, squares, and other diagrams that have been published in, let's say, the last 5 years or the last 10 years, the time frame doesn't really matter. The vast majority of them we do not find in logic textbooks, but really in research papers. Research papers published by logicians for fellow logicians, but also by linguists, by computer scientists, by psychologists. So there is this very interdisciplinary usage that we see, but even more importantly, perhaps, it is a usage by researchers, not just by people who are trying to teach logic to students. It's not just a pedagogical context anymore. When I write a paper and I use an Aristotelian diagram, my goal is that this paper will be read by a colleague of mine, a colleague with whom I stand in a relation that is not one of a student and a teacher, if you see what I mean. So they cannot be just pedagogical devices. An analogy that I like to draw is with another kind of diagrams in physics, Feynman diagrams. So Feynman diagrams in particle physics are also used a lot. And already early on in the 1950s, there was a very important result, a very important paper that said that the formalism of Feynman diagrams is actually mathematically equivalent to another non-mathematical formalism, which means everything that you can do with a Feynman diagram, you can actually also do without. You can in principle also do without. So in that sense, Feynman diagrams are completely useless. They're not really an essential part of physics. But if you look at it from that perspective, you're doing complete, you're not being really honest. You're doing a complete lack of justice to the actual practice of physics. For example, in recent years, a Nobel Prize winning physicist has said, look, the work for which I received my Nobel Prize in physics would have been completely unthinkable without Feynman diagrams. So these Feynman diagrams might be redundant or they might be useless in principle, but they are certainly not so in practice. And the ultimate goal of this philosophical part of the ERC project, and thus of the ERC project as a whole, you could say, is to argue that something similar might at the end also apply for Aristotelian diagrams. And they might be redundant in principle, in the sense that indeed everything that you can do by means of an Aristotelian diagram, you can also do without. But if that is the only thing you say about Aristotelian diagrams, you're doing a complete injustice to them, because they might be redundant in principle, but they are certainly not so in practice. So that's in a nutshell what I hope to achieve with the ERC project, the very logically oriented part, the more empirically oriented part, which is very historically oriented, of course, and then finally the more fundamental philosophical question: why are Aristotelian diagrams useful in the first place?
All right, thank you. So I wanted to take a step back a little bit and ask you, what are Aristotelian diagrams fundamentally? It's an important part of logical geometry and of your project. There are also other kinds of diagrams used throughout the history of logic, famously Euler's diagrams and Venn diagrams. Is there something peculiar about Aristotelian diagrams that sets them apart from other diagrammatic representations of logical relations? So really the question would be perhaps in two parts. What are Aristotelian diagrams, and what is logical geometry, and what is logical geometry's main concern with Aristotelian diagrams, main interest in them?
Yeah. Yeah, so the first part of the question, what are Aristotelian diagrams, I think is easiest to answer by starting from this concrete example that we all know and at least some of us love, namely the square of opposition for syllogistics, with the categorical statements, all men are just, some men are just, no men are just, and some men are not just, and then we put them on the paper in the form of a square. And we say that all men are just and no men are just are contrary to each other, and so on. So an Aristotelian diagram is basically a generalization of this kind of thing. The square of opposition is an Aristotelian diagram, but there are also many other larger, more complex Aristotelian diagrams. And what they have in common is they visually represent a couple of statements from some logical system, could be syllogistics, expressed in natural language or Latin or whatever, could also be propositional logic, predicate logic, some modal logic expressed in a more formalized language that doesn't really matter. And what is really specific about Aristotelian diagrams is it then studies the different logical relations that hold between these sentences, between these formulas, and which I like to call the Aristotelian relations, because some of them, not all of them, but some of them were already studied by Aristotle himself in his Perihermeneias, De Interpretatione. And for example, the relation of contradiction. We say that two formulas are contradictory if they cannot be true together and cannot be false together, but there's also contrariety, subcontrariety, and subalternation, the typical four relations of the square. But you can also use these relations to build larger, more complex diagrams, hexagons, octagons, even three-dimensional diagrams containing many more formulas, and thus also many more relations of this kind, contrarieties and so on. So that is what Aristotelian diagrams are, of course, in a very intuitive kind of way, generalizing from this example of the square of opposition. You could also give a much more mathematically precise definition, but I think this captures the big picture of Aristotelian diagrams. You mentioned these Euler and Venn diagrams, and I would even add to the list many others. There's the Pons Asinorum from medieval logic. There's Porphyrian trees, which are a very early example of tree diagrams. that have also been studied in philosophy, but also in art history and so on. In more contemporary logic, you could say there's also the Hasse diagrams, which are used to study partially ordered sets, post-sets, and so on. Now, one of the things that we really want to do in logical geometry is, and we want to study Aristotelian diagrams as objects of independent interest, both philosophically and mathematically speaking. So that means that the goal of logical geometry is not just to produce new diagrams, more and more Aristotelian diagrams. Of course, a side effect of logical geometry is going to be that we continue to produce more Aristotelian diagrams, but that's not our main goal or our main intention. The primary goal is really to take a step back and look at these Aristotelian diagrams that are being produced 500 years ago, but also 5 days ago, by some computer scientists, for example, or by some psychologists, as I was saying, and try to ask ourselves the question, why do people care? Why do people find it a worthwhile pursuit to illustrate their logical theory or their linguistic idea or their psychological framework by means of an Aristotelian diagram, and both from this logical but also from this more fundamental philosophical perspective that I was getting at. And once you start doing that, once you start looking at Aristotelian diagrams in this slightly more abstract way, you find that they display a very rich mathematical behavior that you can fruitfully study. They're not just tools that we use in order to visualize something else. That's what the actual philosopher or the actual computer scientist does. What we do in logical geometry is we take a step back and we try to investigate these Aristotelian diagrams as objects of independent interest. And for me in logical geometry, the square of opposition is not just a tool that I use to explain or to visualize or whatever, some idea that I have. The square of opposition or the Aristotelian diagram in general is really my primary object of investigation. And I think that is a well-deserved role in the sense that there is enough there that is worth studying, both philosophically, but also both philosophically and mathematically, and in this more empirical kind of sense. One of the ways in which Aristotelian diagrams have turned out to be really interesting, and now I come to the other diagrams that you mentioned, and the Euler diagrams, but also the Hasse diagrams, is it actually turns out that Aristotelian diagrams are not this isolated class of diagrams in logic. If you start studying them in some more detail, you can, for example, show that there are some interesting relationships between Aristotelian diagrams on the one hand and Hasse diagrams on the other, in the sense that certain Aristotelian diagrams give rise to Hasse diagrams and the other way around. And then you can start asking which ones not. Similarly with Euler diagrams. So the work on Hasse diagrams I published a few years ago, I think in 2016 already. In ongoing research that is about to be published later this year, we do a similar exercise with Euler diagrams. And so we show that every Euler diagram gives rise to an Aristotelian diagram. And then the question, of course, is, but what are the advantages and disadvantages of using an Euler diagram instead of an Aristotelian diagram, or the other way around? Because, of course, again, mathematically speaking, it's interesting to know we can translate between the language of Aristotelian diagrams and the language of Euler diagrams. And that's an interesting idea to study mathematically. But of course, the real question, the philosophical question, as I was already saying earlier, is, well, in a given context, what is the best language to use? The language of Euler diagrams or the language of Aristotelian diagrams? Depending on the message that I want to convey with my diagram, it might be more useful to use an Euler diagram. And those contexts certainly exist. I don't want to advocate for the absolute superiority of Aristotelian diagrams in all cases. But there are also other contexts, that's really the point, where Aristotelian diagrams are going to have the more convincing effect. So it will probably not be a big surprise if I tell you that for this kind of research, I tend to collaborate. I really like to do collaborative work in general. I hope that was already clear from some earlier stuff that I said. But for this work in particular, I also like to collaborate with people in psychology, for example, because they really work on, they are able to do eye movement experiments, these kinds of things. What captures the attention? How long are we able to retain attention by a person looking at a diagram? How do they read or process a diagram? How does that differ from an Euler diagram to an Aristotelian diagram? And then indeed you see that for certain purposes, the Aristotelian diagram is more useful, does a better job at achieving what you want, namely retaining attention. And then, for example, you can test this by having people afterwards solve a small test, a small exercise. And then you see, for example, that people who were given a bunch of mathematical formulas accompanied with an Euler diagram perform slightly worse than people who were given the same mathematical formulas, but now accompanied with an Aristotelian diagram. So at least in some contexts, the Aristotelian diagrams, do a better job really at conveying this, conveying these ideas, helping to make clear certain ideas. So I hope that answers at least part of your question.
Yes, sure. Thank you for this very complete answer. I have another last question about methodology. I think, as you were just saying, your objective study is Aristotelian diagrams, and you have an independent interest in them. And I think your object in this regard comes in a shape that it has an historical and sort of a contemporary dimension. And often in your work, these two areas seem to cooperate a lot. I was meaning to ask, what is your own personal take on this? Generally, perhaps on how do you see the relation between the use of formal methods and history of philosophy, history of logic in particular? How do these things relate from your perspective?
Yeah, good. Yeah, that's a wonderful question, but also a very difficult one. So in my own work, I try to combine, on the one hand, very contemporary, formal, mathematically oriented work, with, on the other hand, very historically oriented work. To some extent, these two are apart. Some of my papers are just formally oriented, some are just historically oriented, but I think some of the most interesting ideas really spring up at the interface between the two. So in a sense, the interface between the historical and the systematic work is really interesting, but on the other hand, at the same time, also very dangerous, because of course, when you start doing historical work from a contemporary perspective, if you start formalizing medieval theories of logic, for example, there's a very real danger of anachronism that you might run into, that I myself try to be aware of. It's not always easy to continue to remind myself of this danger. So there's that's really like a philosophical danger, I would almost like to call it. Make sure that you stay true to the text. Another difficulty or another challenge that I myself am often faced with is, of course, the number of skill sets or of kinds of expertise that you need to do this kind of work. Ideally, if you want to do this kind of work and you want to do it well, you had better be an excellent logician from a contemporary perspective. You better know your mathematical logic, let's say. But of course, you also need to know Latin and ideally also Greek. You need to know a lot of the historical context. So you need a lot of historical erudition about the specific context in which a certain author wrote. You need paleography for certain research projects, and so on and so forth. And it's basically impossible for a single person to have all these skill sets just in one head, and your head would explode, I think, if you have those. So why am I saying this? Because I think it's really important to emphasize, or at least that's my conviction, but one which I hold very dearly, that this kind of research on history of logic is typically the kind of research that is best done when it is done in a collaborative fashion. I was already mentioning about my collaborations earlier with psychologists, but also very strongly with people in history of logic, like, for example, Christoph Geurens, Raf van Rooij, names that I already mentioned earlier, who have sets of expertise that partially overlap with my own, but that are first and foremost complementary to my own. And in that way, for example, Christoph Geurens and I have been able to work together, for example, on ancient logic, on the modal square of opposition in Aristotle, which led to a nice paper, I think, which really combined Christoph's great philological expertise to really read the Greek text, but also my own more formal mathematical expertise. Together with Christoph, I've also worked on a relatively little known logician here in Leuven at the very beginning of the 16th century, John Fabry, which Christoph also studied in the context of his doctoral dissertation, although the stuff that we did together was on modal logic, whereas in his doctoral dissertation, Christoph was primarily looking at the topical logic of Fabry. Yeah, and there you see that it really takes these different skill sets. It really takes these different people that come together, each contributing their own skill set, and then I think you can achieve some really nice work in the context of logical geometry. And also, maybe to return one final time to the ERC project that is about to start, this is going to be very important. My goal is really, and one of the things that really makes me happy with the ERC project is it will allow me to hire multiple people, not just a single person, but 4 people in total over the course of the next few years. And why is that so important? Well, because it will allow me to hire, on the one hand, if I may use stereotypes or prototypes here, it will allow me to hire a mathematician and a computer scientist with whom I will collaborate in a really interesting way, but also, let's say, a historian of philosophy, a linguist, and so on and so forth, so that they can all contribute with me and with each other to do this kind of research, because I think that's really important. I was already saying earlier, what we do in logical geometry is we look at these diagrams as objects of independent interest, and that's absolutely true. But on the other hand, there's also the danger that you start looking at diagrams in complete isolation of the context in which they were produced. And so, for example, if I put on my mathematician's glasses, I might look at a diagram from 2020, and I might look at a diagram from 1500 and see, oh, mathematically speaking, they are really closely related to one another. And that's an important insight. Also, philosophically speaking, might be interesting, because it means that everything we know about one diagram maybe is going to transfer to the other diagram. So you get a lot of transfer of knowledge. So that's very good. But of course, the danger is that, well, yeah, you are now viewing this diagram from 1500 in complete isolation from its intellectual context. And of course, that means that you are losing something if you are, and similarly, of course, with the contemporary diagram. So when I look, for example, at a diagram that is produced in contemporary psychology, on the one hand, I try to look at it independently of its context, but on the other hand, it's also important to look at it as embedded in its own cultural, philosophical, scientific context, which is going to require collaborating with contemporary psychologists or linguists. Similarly, if I look at a diagram from 1500, on the one hand, it makes a lot of sense to look at it independently of its context. Mathematically, that can be very fruitful. But on the other hand, it's also important to look at it as embedded in its own context. And for that, it is going to be necessary to collaborate with people who have a great deal more expertise than I do in that historical period, that specific author, and so on and so forth.
Okay, that's, well, I'm really happy that you could give us so nice answers, and you could teaches a lot about Aristotelian diagrams and also about the current projects. I would just like to finish this off by thanking you then for this nice interview for IPM.
Well, thank you for the interesting questions.